Okay, honors pre-calc kids. I've got a couple things I wanted to say about these graphs of the trigonometric functions, the parent functions. So these are not quasi, these are actually the parent functions. So we have first the cosecant graph. The parent function y is equal to CSC of x when you see it, and the secant y is equal to SEC of x, and then you have the y is equal to cotangent COT of x, okay? So when we look at these, when you graph, I just wanted to go over this very quickly. If you look at the first graph, I have the yellow highlighted sine graph because that's the reciprocal of the cosecant. So when you graph this, as I went over in class today, I graph the sine function from negative 2 pi to 2 pi. And then once you get the sine graph done, then you're going to put the vertical asymptotes wherever, let me put some green highlighter on this. So wherever sine is equal to 0, then the cosecant is undefined, of course. So you see I go right through those x-intercepts of the sine graph. And then after that, now this is a real quick lesson on it. We have some other points that we're going to verify tomorrow. And we're going to go through building a table of values and looking at the translations and such. But if you look at where I build my graph, we said that the reciprocal of 1 is 1. So that gives you a good place to start. So you can see that these purple graphs share that maximum point on the graph of the sine, and that will be the minimum on that part of the cosecant. Same thing here. The maximum point on the cosecant is the minimum point on the sine for these two, okay? So there you go. And then we have the domain is x can't be k times pi, where k, remember that z is an element of the integers. So then we've got the range is y can't be on that interval from negative 1 to 1. Now that's kind of a sloppy way to write that. I'll talk a little bit more about that tomorrow. There are no x-intercepts. If you see the purple graphs, they don't reach the x-axis. In fact, you can't take on, and the function can't take on any values between negative 1 and 1. So the y-intercept, there is no y-intercept because you have a vertical asymptote on at x is equal to 0. And if you can see, I have all of the asymptotes listed there. So that when we talk about that, the asymptotes are related to the domain up top, and it's just where I say x cannot be k pi, where k is an element of the integers, the asymptotes are the equations x is equal to k pi. The amplitude is 1, the period is 2 pi, and then to consider the transformations, the a that you see here is the amplitude. Okay, it's still, we consider it amplitude, even though it's not the up and down kind of thing that you see with an amp meter for electrical current, but it's still giving us that distance that's stretched or shrunk. And then the b value is going to help give us the b for the period, 2 pi over b. It's the same as the sine or cosine. And then the c is going to give you the translation. So if the c down here is plus c or minus c, then plus c you move to the left, minus c you move to the right, and you guys know that. And then the d plus d, you move up, and then minus d, you move down. And these are, the c and the d are the same on all of these. The secant, if you notice, I have the yellow is the cosine graph highlighted. The blue cosine is highlighted in yellow. So I graph that first. Then I say, where is the cosine equal to 0? So where the cosine is equal to 0, then the secant is undefined. So you see we draw our vertical lines there. So that will mean that the graph of the secant will approach infinity or negative infinity at those lines, okay? So when you draw them, remember you're drawing them, let me go back to purple here. So we'll start over here, and we'll start at the maximum point on the cosine graph and go up towards the asymptote. And then we'll start at the minimum and go down, kind of like little parabolas, right? And that's what we're concerned about here today, just kind of getting the basic idea of the parent function. Okay, this one's going down, the minimum point, and going down, and then we have one more maximum point, and we only have half a graph here, but we'll kind of complete it there and have to go off the graph. So in this case, remember the domain is x such that x cannot be 2n plus 1. Remember I said 2n plus 1 is an odd number, where 2n is an even number. So 2n plus 1 times pi over 2 gives us all the 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, either positive or negative. Okay, and as I had said before, 2n plus 1 can be either positive or negative, but it's odd. So then the range is y can't be between -1 and 1, same as the cosecant graph, and there are no x-intercepts because you can't have a value of 0 in between -1 and 1, which is eliminated. Then we have the y-intercept in this case is 0, 1. The cosine and the secant graph share that y-intercept. And then the asymptotes are x equal those domain restrictions you found in the domain. And then the amplitude is 1, the period is 2 pi, the same as the cosine or the cosecant graph. And then now you had the cotangent, and I wanted to go over this because I think tomorrow what we're going to do is we're going to talk about graphing and how we get some of these graphs. And I have some old precalculus notes there from back during the Civil War. So what I want to talk about with this is that when we graph the cotangent, we recognize where cotangent is undefined. Very often it's helpful to look at a unit circle and see where cotangent on the unit circle, cotangent theta is equal to x over y on the unit circle. So you can see when y is equal to 0 on the unit circle, that's on the x-axis. So you can see you have your 0, your pi, and your 2 pi are those angles on the unit circle where you hit that y equals 0 mark, right? So you can see x cannot be those values. You have vertical asymptotes at that point. So that would be the first thing I would graph, is I'd recognize where the vertical asymptotes are on the cotangent function. Then I would want to graph one period. The period is pi over b. In this case, b is 1 with the parent function. So it's just going to be pi. So every pi units, I'm going to have a repeat of the cycle. So all I really need is 3 points for this graph. You know, when you give me a real quick general graph of the cosecant and the secant, you're just going to have, you're going to meet the max and the mins, and you're going to draw upward or downward parabolas. It should look like that. But then with the cotangent graph, what we're going to do is we're going to graph using 3 points. And so from 0 to pi, the middle of that graph is pi over 2, and the cotangent of pi over 2 is 0. Now, again, you can use your unit circle to look at that. The cotangent is the x over the y on the unit circle. Not the same x as this x, okay? So then, let me get a different color here, purple. So what we would do is we would graph and we put these 3 points on. So the cotangent of pi over 2 is 0. The cotangent of pi over 4 is going to be 1, and that's this point. I'll make it really big and then decrease it, okay? And then the cotangent of 3 pi over 4 is right here. So we have those 3 points. And then you have to kind of know that it's a curve and it's going to come down like this, okay? Head up towards the vertical asymptote, x is equal to 0, and then it's heading down to -infinity at x is equal to pi. So the domain, x cannot be k pi. You have the vertical asymptotes there. And again, here you have that equation for the asymptote. The range, though, is -infinity to infinity. All real numbers are included in the range. Now, the x-intercepts, to get an expression for that, you've done this before, where you say pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So that's just going to be these. These are going to be the x-intercepts. That is where you're going to cross the x-axis. Then there are no y-intercepts because you have a vertical asymptote there. And then the amplitude, we could say in this case it's 1, but it's really not. There's no stretching is all. It's not really an amplitude like you would think of it, but it nonetheless is an a value in front, and I'll talk about that in the next thing. So, and the period is pi for that. So pi, and then it'll be pi over b down below. So pi for the period for the cotangent, which differs from the cosecant, the secant. So cotangent and tangent have a period of pi. Okay, and then down below, you have the transformation equations, which I wanted to touch on, and we'll deal with those tomorrow. So I'll get you graphing more of these. And I think that's where we're going to end the content for the test, is with some graphing tomorrow, and then I'll, of course, give you the study guide for your exam. So you see where you have the first one, the A is the amplitude, so that's right here. And the period is 2 pi over b, okay? And then the transformation of the graph, you have A is the amplitude, B is going to give you the period by saying 2 pi over b here for both. So that's both the secant and the cosecant. And then the horizontal phase shift we talked about, and the vertical shift. And then for the cotangent, it's the same thing. You have A, and then you have your B. Here's your A, and your B is used for the period, but it's pi over B for the period. Okay? So just be aware of what these graphs look like and be prepared for tomorrow, because what I'm going to do is I'm going to have you deal with a table of values. I think it'll be constructive for you to actually see the inputs and the outputs rather than merely doing all of the analytic kind of graphing like you would with y is equal to mx plus b. You need to really understand some more things about the actual function values, inputs and outputs. So with that, I'm going to say goodnight, and I'm going to open up a couple of keys for you to check your homework for 2.10 and 2.11, and then I will see you tomorrow. Have a great night.